So I am a research scientist at Moscow State University in Russia. So our group is a group of Professor Antipov, and we work on cathode material, anode materials for sodium-ion batteries. We design their composition.
Yes.
We design their synthesis procedures. We develop the methods to study these materials in our laboratory. And so mostly our focus is on cathode materials with polyanionic structure.
Yes.
Also, we do some research on layered oxide materials,
Yes.
as well as a bit of Prussian blue analogs, as also hard carbon materials.
Oh.
So my own work is focused on polyanionic materials.
Okay.
So polyanionic materials usually have high stability. They also have very high rates. Also, so we can do some materials with very original characteristics.
Yes, yes.
For example, we can do low cost per kilowatt hour per year,
Yes.
or low cost per kilowatt hour per cycle.
Yes.
So these are the things which are needed in some backup power devices, at some things which you just put, you need high power, and some seldom.
Yes, yes.
So for example, like for 10 years, you need this device.
Yes.
So polyanionic materials are very good for this. Point of view of stability, polyanionic structures are very stable because of the very strong bonding in the crystal structure of these materials. So if you want the safety, so that your cathode material is not have any degradation, for example, at high rates or at high state of charge, and probably at high temperatures. So polyanionic materials is very good. So you can see the analogs in lithium-ion batteries, that lithium iron phosphates are also preferred for safe applications.
Okay.
More than layered oxides.
Okay.
The biggest challenges are the energy density for polyanionic materials.
Okay.
And one of the biggest challenges is volumetric energy density for polyanionic materials. So I think that for some energy storage systems, like in backup power or other devices, where the volume is not the big issue, but the cost is very important, so their sodium-ion could also take its part. Due to their electrochemical characteristics, due to their composition, that will be a choice for low temperatures without any heating. Battery field is very much developing these days, and sodium-ion battery is developing even higher, and students have very big chance to do a high impact on what is happening today, and they could be they can shape the future with their developments in the lab, or not only in the lab, just in different companies. They could come to a company and do their, for example, some marketing thing that will produce, that will push sodium-ion batteries to the market. And I think that will be a big challenge, and this challenge is will be well deserved if they will succeed. I think with the development of technologies, there are many niches which urgently need sodium-ion batteries, because this is the technology which is just between expensive lithium-ion battery and cheap lead-acid batteries. And you should see a compromise between their advantages and disadvantages. So that's just a niche which fits many, many future applications. Less maintenance, and also you probably have a bit higher capital cost, but you have lower operational cost. These days on this conference, I met several BWatt employees, and I really enjoy talking with you, and I think you have great minds, and I think with your spirit, you could do great things in sodium-ion battery industry.